Okay, today is day 2 in chapter 4, and we get to do a little golf and a little billiards problems. And what end up happening is, what we're going to do today is find the mathematical path to do like a miniature golf problem. Like, you see, here's the ball, it's on a tee right here, and we want to hit it into this hole. But the problem is we can't hit it in one shot because there's some sort of barrier in the way. So what we have to do is bounce it off the walls. Okay? And many of these problems, they'll tell us how to bounce it off. They'll say draw a path from the tee to the hole with a bounce off wall X and wall Y, so they want you to bounce it off on 2 walls. Well, what ends up happening is when you do this problem, mathematically it's got to be on a flat surface, okay, like if this was a real world golf problem, and you've got to hit the ball with no spin on it. You're not allowed to spin the ball. If you do that, whatever angle this ball, if the ball went this way, whatever angle it hits the wall at right here, called the angle of incidence, right? That's called the angle of incidence. Then the ball will bounce off that wall at the very same angle. These 2 angles right here would be congruent, and that's called the angle of reflection. The angle of incidence always equals the angle of reflection when there's no spin on the ball, everything's flat, you got a flat wall, it wasn't curved or anything like that. So it doesn't work that way at a Precision Valley golf course because the walls are all made of jagged rocks and stuff like that, but it does work at junior golf, which is next to Subway. Hopefully you realize that also, like if you hit a ball at a wall, it's going to bounce right back at you, right? The angle of incidence is equal to the angle of reflection. Right there. So here's how we get started. These are our notes. It's a real short day of notes, but the first thing that we're going to do every single time is write the path. And I want you to keep these steps off to the side, out of the way, over here to the right. So step 1, first thing you do in a golf problem, write the path down. What that means is, where is the ball going to travel? Isn't it going to go from the tee to wall X to wall Y and then into the hole? That's what they're asking us to do. So we'll write our path like this. Capital T, since that's a point. The ball is sitting right there. It's more like a point. Then we want it to hit wall X, which is more like a line. It's a segment, you know, so more like a line, so a lowercase cursive letter. Then we want it to hit wall Y. Then we want it to go in the hole, which is more of a point, so that's a capital letter. From T to X to Y to H, we want to write that path down. And that path is important because the way we're going to do this mathematically is by way of reflections. So the second step is we want to reflect this path backwards, meaning we want to take point H and reflect it over line Y. And I like to put these little swoops right here. Now I know your picture is very large compared to mine, and this hole is really big, so in the middle of it somewhere, just put yourself a point and call that H right here, and let's reflect H over line Y. Remember, the first thing we do is we're going to extend Y out longer with our straight edge, so let's get that done right there. Then let's take H and actually reflect it over line Y and call that point H prime. So please get that done. Now that that's done, so I'm going to go back to my path, and I'm going to continue to work backwards. So I went from H to HY. Excuse me. I've taken H and reflected it over line Y. Now I want to reflect over line X. The question is, what should I reflect over line X? You want to reflect this new point right here every single time. We are done with the hole. All done with it. Used it up. We've created H prime for a reason. We want to reflect that point right there over line X. So we want to extend line X out very much longer. And I put this as an asterisk right here in our rules. It says always reflect the new point. It's the one with the most primes on it. We'll see how that works. But let's extend line X out longer. And you might just turn your paper to where this line that you just drawn right here is running straight up and down, if that helps you. And reflect H prime over that and put it way up here where it belongs. And you call that H double prime. Right? That's just got 2 apostrophes next to it. Okay, now that I've reflected that, I continue to go to my path and work backwards, and I am at X, and now I get back to T. I get back to a point. Right? I'm done with lines. There's no more lines. That means I'm done reflecting. So reflecting is done and over with. Now what I want to do is I want to connect the dots together in the right way, and how we do that is we always connect forwards from the T to the highest prime point. We use our path forwards. We want to connect T to the highest prime point, and when we draw that segment, it should go through line X right here. So it's like if I want to go from the T to the highest prime point. Don't connect yet, because watch what we're going to do. But if I do connect this right here, would you believe that this is where the golf ball is actually going to go? Okay, but the golf ball isn't actually going to land all the way out here. Isn't it going to hit wall X and bounce off of it? So what I want you to do is, when you use your straight edge, I want you to make this part of the line solid and imaginary dashed, that is, on the outside. Inside the golf path solid, imaginary on the outside. So go ahead and connect, just like that. Okay, so solid on the inside, imaginary on the outside. And then, would you believe that the golf ball has went from the tee to boom, right there. It hit the wall X. At this point, it's going to bounce off this wall. And mathematically, it is going to bounce this direction, right towards the next prime point, that direction. So when you make this segment, again, solid on the inside, imaginary on the outside. Go ahead and get that done. And do you see this right here? Do you see, you don't have to put any markings here, but do you see the angle the ball hit the wall at, that angle of incidence? Doesn't it look exactly the same as the angle it left the wall at, the angle of reflection? Angle of incidence equals the angle of reflection. So the ball has went from the tee, boom, to wall X, bounced off it, boom, hit wall Y. It is now going to bounce off there, and where's it going to go? It's going to go into the hole. That, my friends, is the mathematical correct path for that to happen. That's math. It will work perfectly. Physics is a whole other deal. For you to get this done, you have to hit the ball hard enough. You have to actually figure out where that point is on the wall. You hit this point right here, bing, the rest will take care of business, but you actually have to physically take your golf club, hit the golf ball, and actually hit that point. So physics is a whole nother ball game. The math is perfect. The physics is real. That's why some people are really good and some people are not so hot at sports like billiards or miniature golf or stuff like that. But there's 3 steps. We're not quite done. To get this all finished, the 4th thing you have to do is you have to put arrows on this blue path right here to show which way the ball is rolling. And isn't the ball going this way, then this way, then this way? Give me some arrows to tell me which way the ball is rolling. So there's our 4 steps. First thing we do, write the path. Second thing is we reflect that path backwards, and always reflecting the new point. That means the one with the most primes on it. And then we connect that forwards, once we're done with that, from the tee to the highest prime point, meaning this had 2 primes. 2 is a higher than 1. You know, if there was something with 3 primes, then that's 2 is bigger than 3. So let's try it again. This one I had to shrink down because it gets all spread out. Yours is much larger, but let's go with our steps. It says refer to the billiard table below. Billiards is just like pool, except there's no pockets involved. The game of billiards was they wanted to start with 1 ball, bounce it off so many walls, and hit the other ball. It was kind of like a challenge game. It's like, I can take ball V and bounce it off these 3 walls and hit ball W. That was the whole point of it. So it's a little different than pool. But draw the path of the ball that starts at W, bounces off C, B, and A in that order, and then hits V. So let's start with rule 1, write the path. Booyah. We want W to go to C, then to B, then to A, and then finally hit wall V. Now we want to reflect backwards, so we'll take ball V and reflect it over line A. So let's extend out A very much longer and reflect V over that, and we'll call it V prime. So extend it out A. Boom, V prime. Now I continue to my path and I work backwards. I now want to take that new point and reflect it over line B. So I'm going to have to extend out B very much longer. And we'll then reflect V prime all the way down here and get this out of my way. And call that V double prime. If you need to turn your paper, turn your paper. And I'll go back to my path and swoop backwards, and I need to get to C. So I want to reflect over line C. C is a line, so I'm still not done. And I'll extend line C out longer and reflect V double prime now. That's the newest point. Reflect V double prime over line C. So we got that over here, and we call that V triple prime. And then we swoop back one more time and we get to W, which is a point, so that means I am done reflecting. Done reflecting. It's now time to connect forwards. Start with W and start with W and connect it to the point with the most primes on it. That's V triple prime. Solid on the inside, imaginary on the outside of the actual billiard table. And then is where we kind of forget how to connect things together. I see lots of people try to connect now this dude to that dude. And that's not right. Okay, the golf ball or the billiard ball is not out there. The billiard ball is on the table. It has went on the solid path. It hit wall C. And what's going to happen is it's going to bounce off wall C and go to the next highest prime point. So you got to remember that that ball, boom, hit the wall. It's got to bounce off of it. So go solid on the inside, imaginary on the outside. And then that ball hit wall B, and it's going to bounce off towards V single prime. So bingo. And then finally, it's going to bounce off wall A and hit ball V. The mathematics is perfect. One more thing to do to finish this problem. What is that one more thing? Put arrows. The most forgotten thing. Tell me which way the ball's rolling. Cool. Now, if you go to the homework packet that I have for you, I'll have you do problem 1 for me. I'll actually do it with you. Draw the path to bounce ball B off the wall and hit ball A. Mark any congruent angles made by this path. We'll do that at the end. But first thing you do is follow those steps. Step 1, write the path. B is supposed to bounce off the wall and hit ball A. So you can call the wall whatever you want. If you want to call it W, if you want to call it wall, it doesn't matter. But did that, and I have also extended this wall out longer. You don't have to go super, super long because it'll just get a mess, but make it longer than it actually is right here. Now it's time to reflect. I've written the path, so I want to reflect backwards. Let's reflect A over the wall. So boom, call that A prime. And then continue swooping back in your path, and you got to B, so done, we're to a point, so it's time to connect forwards, connect B to the point with the highest amount of primes on it, that's A single prime, oops, I went backwards, so boom, and then the ball has bounced off the wall, and it should now hit A. And don't forget arrows. Then they say mark any congruent angles made by this path. You don't have to do that in any problem unless they tell you to, but the angles that are the same is the angle of incidence and the angle of reflection. So, bing, this angle is the same as that angle. They are congruent. Congruent means they measure the same, and we'll define congruent some other day. Okay. And then the rest of your homework, here's what I want you to do. They're having you do 2 problems on one picture, which is a real pain in the butt. So what I want you to do is have 2 highlighters. Highlight just letter A here, one color. I don't care what the color is, right? But just highlight it. Go ahead and do that whole problem. Write the path out right here, B to X to H. That's the path that they want. Then do that problem. Reflect H over line X. So you do that and get H prime right here that I have in red. And then you're done reflecting, so you connect, and solid on the inside, dashed on the outside. Once you're all done with that problem, do you see how I highlighted the path that's only inside the golf deal in yellow? Then I'm going to completely do part B in a different highlighter color. I'm going to write its path right here, do the problem, and I'll highlight it orange is what I have right here. So what I ask is you have 2 different colors. If you do letter A in yellow, do the rest of the letter A's, 3A, 4A in yellow. If you do letter B in orange, do the rest of those in orange. So that's what I ask you to do. If you need some more help, please come in and I will help you. And that's all for today, so have a good one.